So at the end of my internship, I got this thing working for GW1N-1, sort of the bigger device. But then there's also these Tang Nano, smaller FPGAs. And when I tried the code on this FPGA, it turned out there's some weird issues. So I've been refactoring the code to handle other types of FPGAs. So basically, before, what was happening, there's this file that parses the data file from the vendor. And I was using this directly to parse bit streams and do all the things that I wanted to do. But then it turned out that this database format is not consistent between different FPGAs. So, for example, let me show that real quick, maybe. Yeah, sure, doesn't matter. So if you look at this database, basically, what am I going to look at? Let's look at table 12, for example. No, not this one. 66 maybe. It's a good one. So what this is basically, okay, let me backtrack a bit. This file describes all the fuses in the FPGA, and there's a header which contains a grid, and whoops. This grid describes basically for each tile sort of what type it is. So all these are IOB on the edges, and these are sort of normal logic tiles, and then there's block RAM in the middle and more IOB. So if you look at let's look at tile 66. It has this long val, which is whoops. So it has sort of tables within of this type, and 23 and 24 are tables that represent the fuses for the A side and the B side of this IOB. So each tile has two out or input pins. So if you, for example, look at 23, so a long val has 16, I don't know, I call them features, and then a bunch of fuses, and these fuses are an index into another table which gives you the location of a bit in the FPGA tile. But it turns out, so I was looking up bits, fuzzing bits and mapping them to features. But it turns out that these features are not consistent between the GW1N and the GW1N FPGAs. So everything was completely broken that I had done so far for GW1N. So what I decided to do then is make my own database file based on the vendor database and just fill them in with fuzzing results rather than trying to map to these broken data bits. So what this does is sort of, yeah, just like a structure of tiles and stuff. It has a kind of similar structure to this file, but I don't know, it uses my own fuzzing data, so it sort of should be more consistent and usable. So yes, what it does is it takes the pips and LUT data from the views file, which is fairly consistent, and also the port map from another data file, but the rest is done in the fuzzer, which is here. And it's kind of, after rewriting this whole thing, it's sort of not too much code actually. And what I will be working on now is the unpacker. So I wrote this code that can, given a bit stream from either a vendor or my own code, can sort of transform that back to a Verilog netlist. And I've been sort of, yeah, rewriting this and making it work with the GW1N-1 FPGA, which kind of is working, except not completely. So if you go back to this grid, you can see that here on the edges there's a sort of different IOB, and actually if you look at the GW1N-1, yeah, whatever, that's this thing. And if you zoom in, so these all have two things, right? This is pin 10 and pin 11. This, however, is pin 3, 4, 5, 6, 7, and this is 9 and 8. So these things, the special IOB, have 10 pins each. So they're kind of different and break all my code because they're different. So I'm trying to figure out how to fix this basically. And I do handle them partially already, but yeah. So let's see what we have. I have some thoughts on what might be going on, but it might be that we're just going to be stuck staring at me, not knowing what is going on. So yeah, let me just run what I have now, and yeah, so here I just use the IDE to generate a bit stream for this FPGA, and if I run the unpacker, oh wait, this actually, let me check, let me just have to start the IDE to actually like put the things in the correct place. By the way, you have to do some weird stuff to get this IDE working on Arch Linux. First of all, you have to run this license manager, and for me, because I use my Wi-Fi MAC address, I have to enable Wi-Fi even though I'm not using it. What else? I forgot what this was about. Maybe I was just debugging something. But yeah, so you also have to install some compatibility package somewhere to even run this piece of Leap. Anyway, doesn't matter. You can also just you know, run CentOS and be happy with your perfectly Linux compatible code. Yeah, so let's see. Alright, so currently I am not using the special IOB. So what I will do is just put the clock here for now. And let's put it on port 3. Place and put the thing. And then try to unpack it again. Yeah, so 50 is the special IOB tile. So now it did find an iBuff. But yesterday something weird happened, so let me see what happens if I also put the reset here. Because I have the feeling there might be some shared pins between them and I'm not fuzzing them correctly. For example, you can see it's sort of split in 2 pieces rather than 10. And for these, like all the bits are sort of, you know, completely separate for the 2 pins. But it might be that there's some shared bits in this case. So let's see if I put 2 wires on it, if it still even finds it. Yeah, no, now it's, oh yeah, it does. Oh, okay, this is good. This is good. Okay, so let's see, because the code that I have now is basically just on every clock edge invert the thing, so it's sort of a clock divider. It was a blinky, but yeah, that didn't work. So actually this script also outputs unpack.v, which is sort of hard coded now, but yeah, whatever. So you can see that it made this input buffers and output buffer. The thing is, it's a bit complicated to debug this because every multiplexer, wait, can I show this? Oh yeah, maybe. Let's see. Oh. I will show you a piece of my internship report. Yeah, so here is sort of what a tile looks like in terms of bits. So each of these things is a multiplexer that drives some wire, so it could be sort of a mux input or like a LUT input or an external wire to another tile. And they have like a dozen bits per multiplexer because they have like 30 pins each, input pins. They have a really weird encoding, but basically the point is if there's 0-bit set, they have sort of a default state that's also a valid state. So even if this tile is completely blank, all these multiplexers have wires set. So that's also what you see if you unpack it. You get all these wires that basically are not really part of anything. Yeah, so what happens if you clean it? So what this does, it reads this unpack, it reads this sim library, then it cleans all the useless mux that we created, and it shows it. Point is, yeah, see these 2 inputs, they don't go anywhere. Which are the like the clock and the reset that I just moved to this special IOB. I can also remove this clean statement. to just show it as it is without all the extra wires. But it's a bit unwieldy because it's, you know, all these wires that go nowhere. And I haven't found like a clean command that sort of cleans all these wires without cleaning the stuff that I want to see, because what I want to see is also yeah. So here, this is okay. This is a problem here. Here you see sort of the wires going into this flip-flop, and you can see they sort of end in row 6 column 1, and this is the column and the row of this IOB tile. So these wires definitely belong to the IOB that we're trying to map, while where's the IOB itself? Oops. The IOB itself. Where is it? Come on. Oh, here. See? They got port mapped to A0 and A1. And I'll show you where this came from. So there's this other file which is .dat, and I'll show you that these things are version dependent. They're just like a raw C struct that's dumped, so the parser is a bit ugly. And also this was sort of written on the go, so it's not like a clean API. So it just sort of, yeah, decodes this whole thing and then dumps it into a JSON file. So what I want to do now is yeah, open this JSON file. Actually, before I do this, let's make sure we're getting it for the right device. I think, yeah, I have it going 1 now, so I have to run this to get the new JSON file. Pardon. Yeah, so now we have this decoded. And the thing of interest here is, so there's several things. There's IO buff. There's several IO buff things. IO buff A in, IO buff A out, IO buff A output enable, IO buff A IO, IO buff B in, IO buff B out, IO buff B output enable, output B IO. And this, okay, so these are like sort of a normal IOB has 2 sides, right? The A side and the B side. However, the special IOB has 10 of them, which, if you look at, let's see, IOB out, I guess. It's a bit confusing if out means an output pin or the output to the logic, and I think in GW1N terminology, an output is sort of like the output wire of the cell primitive. So the output is what is going into the logic from an input pin. So these are just a bunch of random numbers, basically. But I have a nice table here. I can show you. It's just the mapping of all these numbers to human readable-ish wire names. I think, yeah, I already had it here. I know, I mean, you need a different thing. So for all these things, Just need to look it up. There, that gives you sort of what the wires that it should be connecting to according to this data file. And let's see if this matches. No, that doesn't make sense. That doesn't make sense. So somewhere there's a bug in either the fuzzer or the unpacker. So it could be that the fuzzer set this. Oh yeah, so here there's this part. This is this part of the code. Uses this dat file and sort of the device database to pull this JSON data into the chipdb. So basically, if this tile is just an IOB more than 2 bels, which stands for basic elements, if you don't know, then use this. And this might be just the wrong way around. That could be all there's wrong with it. So the output port of this bell. Yeah, why is that? Is that just backwards? Yeah, as I said, it can be sort of confusing. Okay, let's just, because here I say out, out, and this seems to work. So here it's also in, out, out. Does that make sense? Yeah, let's see what happens if I do that. So I have to make a new chipdb now, which I do by running the tiled fuzzer. The tiled fuzzer is basically, there's 2 fuzzers in this project. This was the first fuzzer I wrote, the first proper fuzzer that I wrote, which fuzzes the entire FPGA, all the bits sort of without assuming anything. And it's quite complex to do this efficiently and correctly. Just like 600 lines and still kind of broken and incomplete. So if I just hard coded this, which one to run. This one uses the same chipdb, or actually Fuse, their file, their database data files, to sort of map which bit belongs to which tile type. So you only have to fuzz each tile type once basically, and you know these bits belong to this tile already. So this makes it a lot simpler. It's like this is the whole thing for fuzzing data flip-flops. It just creates creates a flip-flop and sort of a dummy lookup table. The only tricky thing is that sort of it needs to map, sort of take a it gets a list of locations, and it sort of needs to sort of use a free location of the tile type that it wants to fuzz for that thing. Yeah, so this is IOB, same stuff, but this was a bit more complicated because not all IOB, as you can see here, these are just not used, so you can't put anything there. And for example, this one has only 1 available, so you can sort of use it for A, but not for the B side. So this makes it a bit more complicated, but overall it's like not too much code, a lot simpler than the other one. So yeah, if I run this, I should have run this while talking maybe, so it could run. It's still fairly quick though, so yeah, it just uses all my cores to fuzz all the tiles. And it takes a few minutes, not too bad. And we'll use this library to sort of annotate the port map onto the code. Yeah, you can sort of see here that it put one IO buff on this tile and it set these bits to 1. But I think now if we unpack again the, let's see, this vendor generated thing. So it found the correct buffers still. Now see if we unpack it with clean and purge, if we get anything sensible. Yeah, much better. See, now everything is nicely connected and you can see there's input buffer, flip-flop, into lookup table, which is basically a lookup table with one but these others are unused and the unpacker doesn't know. We'll loop back. So this is basically an inverter and then output. So this works. Okay, so that's part 1 done. Let's see what I've changed. Yeah, basically just stupid backwards typo thing. Something like that. The other thing I want to look at, because now it seemed to work, but yesterday I had a problem where it didn't detect the ports at all. So I want to see if I can reproduce this. Put everything in this single thing. It's stupid that it just select all of them. Because if you do that, it will just not work because some of them are special pins. So let's see, it might just give an error now. Oh, I have multiple floor planners open. That was not what I wanted. Let's see. Place and road. Completed. Okay, let's go. Unpack. Yeah, see, it only picked up these two. It did not pick up the output bits. Well, they are also on this tile in particular, right? If I'm not mistaken, yeah, contains lots of stuff. Oh, basically everything is in the first half now. Okay, okay. Yeah, so I think something is wrong with the way I fuzz this. Yeah, so basically a downside of this simpler fuzzer is it doesn't find sort of interdependencies automatically. This will sort of yell at you if you have a bit that's sort of randomly triggering that you don't predict. Well, this will just assume the thing you set is the thing you set and just take it. So it could be that if you have, for example, both input and output buffers on one side, it will set different bits, and this is not handled. Excuse me. Okay, let's think. Right. Think what I want to do is set a breakpoint on this special tile. No, just let's just look at the unpacker first, what it has. Like what the tile contains and what the unpacker wants it to contain. Yeah, so they have this ugly debug code, which is kind of nice. So we want to break on tile 50, and in this case I don't care too much about. Yeah, I can't hurt to have that DB there too. Yeah, let's see what happens. Unpackaging. Actually, I want to just print the whole tile in ASCII for a bit. So I can see what's going on there, what it has. Yeah, okay, so these are all the bits that are set in this tile. That's a lot of bits. Oh god. Okay, let's start to reduce, sort of, you know, find a minimal test case that breaks. Okay, so what if we do first? Let's try if an output works at all. I don't care, go anywhere you want. No, so I want all the reset and clock to be anywhere but this IOB. And then I want one LED pin on this one. Yeah, just take 3. Let's do it. Oops. No. Okay. Let's try it again. Yeah, this is something really weird that I haven't figured out. So if you put a breakpoint, it will complain about a missing argument. Well, there is no missing argument, it's just broken somehow. So I think I have to basically remove this, or at least move it down so it doesn't trigger, to see what it even found this time. Okay, so single outbuff works. This is good. Wait, let's keep this somewhere. That new thing, right? Yes. Okay, so this is what an output buffer looks like. And then go back. Come on. And let's just put this one there for now. Okay. So this is input buffer. Quite different. Now let's see what happens if we put both an input and an output buffer on it. And this is where it seems to break somehow. Let's see. Based on root. Unpack, let's see what we have. Yeah, so it found nothing. And let's compare what it looks like. This was input, no, output, right? This is so this has 2 pins set basically, right? Buff, put buffer, and so what I'm thinking, sort of this piece is going to correspond to the pins. So you would have like 1, 2, 3, 4, 5, blah blah, so they can row. And these ones seem to more be sort of shared bits, I guess. Because if you see like this one and this one, it shares a couple of bits. And this one also shares a couple of bits. So this is something you have to handle differently basically. But yeah, now we missed the crucial part in the code actually, because here now we have a breakpoint here basically, and we wanted to sort of go in here, but this crashed it, this failed when debugging somehow. So maybe I can just run this like this. Does that work? Why? Why? D type. Oh, this. Do I have multiple parse style functions in here? Am I not so smart here? This is parse style. It's 2 arguments. What? Oh, so it tries to use this one somehow. Which is strange. Why would it do that? Because I'm not even using fuse hex here. This is so weird. just gonna rename this one. I mean, it's already used here, so whatever, I don't care. I'll deal with that later. Or not, I don't know. Yeah, let's see if we can actually set a breakpoint now that it's step into. Yeah, works. That's stupid. Okay, step BD step. Let's see. So we have tile, which is the whole array, and tile data, which is the chip DB, and the wires thing is a bit unwieldy, but the interesting part is this. Right, we have wires 3 and 4, so I'm guessing this would be IOB A and B. Let's see, can we just... Yeah, okay, we'll just loop over the bells. Let's go. Bell, flags. What bell are we in now? Oh yes, it goes further down the list. So to G. Okay, well, G, E, C, A, B, D. So let's keep going until we reach A, because I think A is what we should be looking for. Blah, 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 blah. Okay, A, good. And A has mode. So yeah, a bell, which is the basic element, has flags and mode. The difference between a flag and a mode is that a flag is sort of, it can have multiple, and modes are exclusive. So sort of if yeah, the reason I did this, so if iBuff has all these bits set, all the bits of the other mode should be set to 0, because for example in the flip-flop case, a set flip-flop has like 1 bit set, and a reset flip-flop has like 2 bit set, which is sort of a superset of the set flip-flop. So we'll detect both. So I just said, okay, they're exclusive, modes are exclusive, and flags are not exclusive. But in this case, I think some of these bits are actually shared between the modes. Which means yeah, it will just sort of see that bits of other modes are set and then complain. So we sort of have to find the common bits and move them to a flag or something. Or alternatively, yeah, okay, let's first figure out what's... Yeah, so I'm not quite sure, like, if we find a problem, how to solve it. Okay, let's keep going and see what happens here. so it went over the flag. Why not? Okay, so it got the bits of one of these modes, I suppose. And now it will collect all the bits yeah, so these are all the bits corresponding to all the modes that are set in the style. And now it will go over all the modes basically. And if the bits of this mode are the bits of that are set, then yeah, then it's a match, and then this mode gets added. So let's see what happens. Which mode are we in now? IBIF. Yeah, so you can see it shares some of them, but there's also extra ones. And what should A be? A was our yeah, A was our input, so this one is what should match. And you can see it is a close match, like there's like matching parts. But there's also these other bits. So I think what I will do is go into my Python. Should be somewhere. Yeah, this was what I'm looking for. Just load the database and look around a bit what's going on. So our tile in question is grid row 5. Yeah, by the way, the rows in the floor planner are sort of 1 based, and this arrays are of course 0 based. So if you go here and you see row 7 column 2, that's actually sort of 6 1 in this array. So that's our thing right there. So what I want to figure out is which bits are shared between all these buffers. So they're already set, so I should be able to do some intersection. The question is, what do I want to intersect actually? Okay, let's see what happens if I say I want IOB A. This one, and intersect it with IOB B. Oh, see that? This is what they have in common. Or no? Yes, is it? This is what they have in common. I think. I'm confused about set operations now. Yes. Yeah, intersection, this is what I want. Ah, okay, no, this is not what I wanted. Yeah, so these bits are basically shared between, let's see if we can do this, and see if they're shared between all of them actually. Let's just keep going and see. Oh, no. Interesting. So B and C don't share anything. This is weird. What about C and D? What? Wet. Okay. So these seem to share 4, 1, and these seem to share 4. So what I'm thinking, if you look at the floor planner, there's these two things, right? And in this case, these are completely independent. So I'm thinking maybe there's two sets here, like IOB. Oh, actually, AB, CD, E. Well, this seems to indicate they are like A and B and C and D and E are all on the same thing, and F and G are not. So also here. But on the other hand, it wouldn't be the first time that this is sort of lies was displayed here. For example, if you look at like some parts, they do some binning stuff where they disable half of the LUTs and just like set it for cheaper basically, and it would just like show half of them not there in the floor planner, which is of course a lie. So I'm not like, I don't want to rely too much on this information to go by. Maybe I should just like make a nested loop to sort of compare everything to everything and see what they share. Also, what do iBuff and OBuff share? Nothing. But yes. So yeah, basically IOB are the nastiest part of FPGAs in general. So yeah, it won't be pretty to solve this, and I'm not sure we'll do it today, and yeah, we'll just see until my throat starts to hate me too much for talking, which might be pretty soon. But let's see if we at least can figure out what is sort of going on, and then I think I'll do the actual fixing of this problem another time, because yeah, I still haven't figured out how to actually do this with the modes and the flags. Yeah, okay, let's see what we can do with some loops. Okay, so we have our things we want to loop over is basically just make it a list so I can look at them easy. Ooh. Whoops. Okay. Yeah, okay, that's our IOB. And so for, I don't know, I also want to do this for OPUF eventually, but for now, oops. Let's see. Oh, and actually, print ij. Oops. Why? Okay. Yes, no shit. Okay. If I this G, oops, and okay, so wet. Okay, so you have, yeah, okay, so we have the reverse and doesn't make sense. Okay, so A and B share something, and C and D share something. If we do this for output buffer, let's also share stuff. Yes, is it the same stuff? No, of course not. It's also 4 bits though. Of course, we also have like bidirectional pin, which is, oi, this is a thing, right? Yeah. Okay, so these, what? What? Oh my god. How? Why? Yeah, figuring this out is one thing, because I have still no clue why, what's going on, what this all means. The other thing is, of course, you want to sort of automate this in the fuzzer. So at the moment, what's happening? Yeah, so if it's an IOB, no, first we just parse all the stuff, which happens more, no. Let's see. Yeah, okay, so for this tile, it compares it to the empty tile. No, for the whole bitmap, it just like compares it with, like, XORs it with the empty bitmap. Then splits up into tiles. And then for every post placement element it found in the post placement file the IDE generated, yeah, it sort of decodes that and finds the things. Then I verify that it's actually not using the same tile twice within one run. And print the stuff. This finds all the bits that are 1 in this tile. Yeah, so this gives you basically a tuple, a list of tuples of all the locations that are 1 in this tile. So then you go like, okay, so we put an IOB in this tile, and these are the things that are 1. So, hey, let's see, the row, column, files, the IOB that we sort of found in the post placement. If it's not there, create it. And then cell type, so that would be IBUF, OBUF, IOBUF. Just a list of all locations. So somehow I need to change this so that it keeps in mind. Or I need, probably I need to add another pass to look at it. And yeah, because so I'm thinking if you have like you place one IOB, you run it, you get the bits, and you're not sure like if these bits are shared or not between other IOBs. But yes, I think what I need is sort of a second pass after everything is done to do basically what I'm doing here, something like this, where you go, okay, all these things are shared between these things, so treat them differently. And treat them how is also an interesting question. So there's 2 ways I think you could go about it. One thing you could do is make one big bell, which instead of like an input pin and an output pin has like 5 input pins or 5 output pins. And then you could have sort of the shared bits in as a mode. So it would be input or output or both. And then the flags would be which of the output ports is actually used as what. The other option would be to have different, like have a bell for each pin as it currently is, but sort of move all the common bits into the flags. So sort of the unique bits of each pin would sort of determine its function, and then the flags would sort of determine if the entire tile is like in a certain mode or whatever. I think both options can work probably. I think the later option with like, pins and flags would be slightly less painful to deal with later, because then the placer, you don't need to teach next PNR too much about this special super bell that you just made. You can just like, hey, there's like 10 bells in this thing, but you have to check the flags for stuff. Yeah. I think maybe I'll leave it at this for today, because I'm out of water. I've been going for an hour and I'm just not sure how to actually implement this yet. I would love to hear on Twitter or on chat or whatever you can find me, what you like, what you didn't like, how I can improve, if I should do it again, if I should do it differently. Basically anything you can tell me about how to not do this or do this would be appreciated, because this is sort of experiment to see if this works for people, if it's helpful, if I like doing it. Yeah, so I'll think about this and implement it at some point. Maybe there will be another stream, maybe I'll do it offline. And I guess that's it today. Thank you all for stopping by, and let me know what you think.